Let's see an example of how we use linearity in a really basic series circuit with a voltage source. So this circuit looks really similar to the one that we used to introduce the concept of linearity. We just have a DC voltage source and two resistors in series. So I'll let this be 1 volt to start with, and then I'll have one of my resistors be 1K, and then we're interested in the output voltage, so the voltage drop across the 4K ohm resistor. And suppose we're asked to find V out if V in is 1 volt, 5 volts, and 7 volts. So the first step for these problems is we want to find an equation for V out in terms of V in. Find an equation for V out in terms of V in. Okay, great. So this is a series circuit, so we know that the current is going to be the same everywhere in this. The amount of current that is produced and supplied by this voltage source is going to depend on R equivalent. So using Ohm's law, we have that our source voltage is equal to I times R equivalent. So in this starting case, our V in is 1 volt. Here's our I. Our R equivalent, since these are in series, is 1K plus 4K. So this is 5K ohms. So our I is going to be 1 over 5K. Great. So then I'm interested in the voltage drop across just the 4K ohm resistor. So if I apply Ohm's law just to this resistor, I'll get that V out is equal to I times the 4K ohm resistor. Okay, so then this I is the same as this I since this is a series circuit. So I can write this as 1 over 5K times 4K, and this is this should be 4 over 5. Okay, great. So this means that my V out in terms of a V in being 1 is equal to 4 over 5. If I were to write my general equation would be V out is equal to 4 over 5 times V in. Now, to answer the rest of my question, I want to be able to do this for varying source voltages. So I'm going to calculate V out for V in equal to 5 volts, so that will give me 4 volts. Calculate V out when V in is equal to 7, and this is going to give me 28 volts, 28 over 5 volts. Okay, great. So conversely, if we replaced this 1K ohm resistor with, say, an unknown resistor, and we were asked what value of R1 of this unknown resistor would make our V out 50%, 25%, or 75% of V in. Okay, so let's look at this same problem from a different direction. Suppose we're asked something to turn this around into a different problem. So using this same circuit, now suppose this stays as a 4K ohm resistor, but this one is unknown. So now when we're designing our circuit, we want to figure out what this resistor should be in order for V out to be 50%, 25%, or 75% of V in. What are value? Okay, great. So if this is our V out, to write our equation, so the first step is we still want to write our equation for V out in terms of V in. So this is our V in, this is our V out. We don't know what this resistor is, so I'll just call it maybe R1. Now, to find this current, this is going to be, using Ohm's law, Vn is equal to I times our equivalent in this case is R1 plus 4K because it's a series circuit. Then at the 4K ohm resistor, we apply Ohm's law again and we get V out is equal to I times 4K. Now what we can do is we can basically substitute this equation into this equation by replacing this I with that I. So if I rearrange this term, this means that I is equal to Vn over R1 plus 4K. If I take this and I substitute it in for this I, then I get V out is equal to Vn over R1 plus 4K, and this thing gets multiplied by 4K. Okay, great. So I'm going to rearrange the terms so I have my constants together. Okay, so these are all my R values and multiplied by Vn. So now I have equation for V out in terms of Vn. So this thing right here is my scale factor. But we're asked to find what value of this unknown resistor R1 will give us a V out of 50% to begin with. Okay, so the second part of our problem, to get V out equal to 50% of V in, well, check this out. So if we have V out is equal to K times V in, then if V out is 50% of V in, that means that the ratio of V out to V in should be 0.5. And then V out to V in, that's just equal to RK. And if I took this thing and I divided both sides by V in, I'd get my V out over V in is equal to K. And so this is going to be consistent. My K that I figured out up here is 4K over R1 plus 4K. So now what I can do is I can solve this equation for R1. It is 0.5 is equal to 4K over R1 plus 4K. So this means that R1 is equal to 4K divided by 0.5 minus 4K. So that means that R1 would have to be a 4K ohm resistor in order for the ratio of V out to V in to be 50%. Okay, so now we can repeat this for 25%. So that means that V out over V in, the ratio would be 0.25. That's equal to 4K over R1 plus 4K. So this implies that R1 would have to be a 12K ohm resistor in order for our ratio to be 25%. And then lastly, if we want our ratio to be 75%, then 0.75 is equal to V out over V in, which is equal to K, 4K over R1 plus 4K. So this implies that our R1 resistor would have to be 133 1/3 ohms. Okay, so what we did here is we're the engineers, so we get to pick the appropriate resistor here that will give us the V out that we want in terms of the source voltage.